Type is a first instantiation of the aBPR conceptualization presented in our paper, an assisted approach to business process redesign. And it's developed as a web application based on the Camunda modeler and the BPMN.js library. The application starts from an empty canvas or from an existing BPMN diagram and supports the user in annotating and editing a process model, and also recommends redesign options, we call recommendations, to the process model along defined performance objectives. So time, cost, quality, or flexibility. The user can apply these recommendations and evaluate their impact with simulation experiments. This procedure is repeated until satisfaction with the process model is achieved. For our demonstration, we look into a process that handles service requests. They are received and evaluated in the beginning based on their urgency, and therefore handled differently in the following. Urgent requests are directly handled by involving a supplier who solves the request and confirms the work is done. For less urgent requests, a supplier is evaluated and it is decided whether a preferred supplier can handle the request or if a new supplier needs to be contracted. Either way, the work is scheduled, executed, confirmed as being done, paid, and finally closed. We make use of simulation to evaluate the performance of process models. Therefore, the application allows to define and model the simulation experiment for all elements in a BPMN process. Simulation properties can be defined, for example, for the arrival rate for the start event with different types of distributions. Also, the duration of activities can be modeled with an optional setup duration for each task. At branching gateways, we can model the branching behavior with branching probabilities. To model the behavior of resources, we can use the BPMN collaboration diagram, where each resource corresponds to one lane in the diagram. For each of the resources, we can give a quantity and cost information and assign a timetable to build on the extensible BPMN process simulation engine Skilla to conduct the simulation experiments, and can immediately watch the simulation experiment after starting the application, seeing information on time, cost, resource, and activity behavior. This allows us to validate the first model of the process and later to compare different versions of the process model. The main contribution in our approach lies in the intelligent recommendation of redesign options. The recommendations are based on redesign patterns, also called redesign heuristics. They constitute lessons learned and good practices from previous projects and help to think about process improvement in a structured way and guide the search for new process designs. Examples for these patterns are parallelization of tasks, the removal of non-value-adding tasks, or empowering workers to make decisions themselves. From related work, we learned that many of these patterns can be applied automatically, as long as data is provided. Yet, for a holistic process improvement, the incorporation of domain expertise is essential due to missing data in process models, implicit assumptions, and process knowledge beyond the model. This constitutes a limitation for these purely automated approaches. Therefore, we have conceptualized 4 types of recommendations of varying level of automation that assist in the best possible way. Before demonstrating the application, let's note that their application always follows the same procedure. First, find a suitable redesign pattern that helps to achieve the performance objective. Second, identify where in the process this pattern can be applied. Third, create an actual redesign of the process. And 4, evaluate the performance of the new redesign. Now let's start. Therefore, a performance objective is defined first. Let's focus on the improvement of time here. Immediately, redesign recommendations are created and displayed in the list of recommendations. We will see that this list grows as we calculate further recommendations in the background. Let's start with the most basic type of recommendation that we call an idea. They are supposed to give nothing more than an idea of which redesign patterns might be beneficial to the process at hand, without further analysis. We can, as a user, browse through this list of ideas and recommendations and select the Empower idea. We completed step 1, finding a suitable idea. Let's continue with step 2, identifying a part in the process model to apply this idea. We can see that the activity, schedule supplier, is executed by the planner resource. And we hope that this planner resource takes some time to think into the case before scheduling the supplier, and hope that by empowering the worker resource will save us some time in the process. To redesign this process, we can simply move the task from the one lane into the other lane, the employee or worker lane. All changes to the model are tracked on the right-hand side, and we can see that the model has indeed changed. Now, hoping for time reduction, we adjust the expected duration for this task and see that also this change is reflected in our change set. To evaluate this idea now, after completing step 3, the actual redesign, we want to perform a simulation experiment. This happens in the background, and as soon as the experiment is done, we can compare the two versions of the process side by side, seeing that the redesign has not only saved us some time, but is also most likely to save some money. At this stage, we can choose to either accept or reject this redesign and discard all changes. For this demo, let's discard the changes and see how other types of recommendations can help us. At the top of the list, we see those recommendations that are supposed to be most helpful and at the same time quite specific. Several recommendations, for example, suggest to put some activities into parallel. They also give an indication about their specific impact on the process model. These are the most advanced type of recommendations that we envision, completely automated advices. In the background, our pattern implementation first found the pattern, then detected activities that can be put into parallel based on the control flow and data input-output dependencies between the tasks, created a redesign of the process, and already run a simulation experiment to start the evaluation. As a user, we can therefore simply apply the redesign and immediately view the results of the redesign and see if this redesign is useful to us. The recommendation to apply the triage pattern to the register request task is now based on the additional information we just provided. Let's apply this pattern. A new wizard will pop up that guides us through the redesign. We can create alternative tasks in a guided way. The process model in the background is automatically updated and all changes are tracked. We hope that a certain amount of these activities can be automated with an automated resource. We therefore configure the automated resource, the planner resource, and decrease the time for this type of activity, which accounts for 90% of all cases. The remaining 10% default activities are treated just the way they are used to. We can exit the wizard and see that the data model, the process model, has automatically been updated. Again, we can commit our changes, execute the simulation experiment, and evaluate our simulation results. The aBPR prototype is open source and can be extended with further implementations for recommendations. We have evaluated if the aBPR prototype is open source and can be extended with further implementations of recommendations. We have applied it The aBPR prototype is open source and can be extended with further implementations for recommendations. We have evaluated it with experts from academia and practice and applied it in several case studies. In case you have any questions, feel free to reach out to the authors. Thanks.